It's time to introduce map, filter, and reduce utilities in function. Starting with map, map is a utility function which maps a collection to another collection objects based on a certain functionality. Let us start with a simple example. The example here is that we have this list of country names, right? And just recently we learned how to use lambda function here to define a function. We want to define a function that would basically get an input, a single input, and just make it, let's say, uppercase or lowercase, right? Okay, so let me use lambda to do so. So if you want to define a function, which is basically just a simple upper function, but f would equal to lambda x.upper, and that's it, right? So you can, if you do this, and then later on you apply, you call this function and pass, let's say, the string India to this function, you would get the all capital letter version of the string India. So if you want to apply a function on a single element, we've noticed that lambda is a proper way to do it in a single line and in a somehow elegant way. What if you want to apply this function onto the entire list of countries that you have here? Well, one way that we are familiar with is to use the for loop like this, right? Let me just do that. And then you can see how map would makes our life easier in that sense. So for country in countries, you can get the name of the country here, call the function f, and you can have another list, right? You can have another list, capital countries. It's an empty list, and you can append the output of this function to that list. So what I'm doing here is that I'm just creating an empty list, applying the function that I've just defined, which just does an uppercase of a single string, and append it to that empty list. Once I'm done with this, if I looked at the capital countries, it should contain the name of the same list, but with each string all the letters capital. That's one way to do it, and that's normally the first thing that may come to your mind. The map utility would give you a nicer way, like the list comprehension approach, to the problem of applying a function to all the components or elements of a list, and that's how you do it. So you should go with map keyboard. At one side, it gets two input. The first one is the function. So you can either put f here, or instead of f, just put the definition of a function. The second input to the map is the list or the object or a collection on which you want the function to be applied. I have countries here. If you do this, it will tell you that it has created a map. It's just like an object, and you should kind of cast it to a list to see the output. So the map takes two input. The first one is the function, to be more accurate. So map takes two input. It's the function that you want to apply. Here we have used lambda version of a function, and the collection or list over which you want to apply this. So if you do list here, you can see that actually the list here is just casting the output of this map to a list so that you can visualize and print it. So what we have done here is that we have used map to apply a function to a list of objects or elements or strings or variables in an iterative way without explicitly using for loop. Better example and comprehensive one where we want to write a program to count the students above age of 80. So you are familiar with this students data dictionary that we had in the past. I'm just gonna paste it over here and have it printed. So this is very similar to the dictionary that we had, where the index or the keys are just a number and the values are the name of the students and their age. This is in the form of a dictionary. So our input is a dictionary. It's not a list this time, it's a dictionary. What we'd like to do is that we would like to count the number of the students that are above 18. Okay, let us do that, and let us use filter to help us do that. Again, there are kind of like there are more. You can use a for loop to loop through this dictionary and add a condition if-else statement inside the for loop to filter out this or count the number of students above age 18. We are trying to use a combination of lambda and filter to have a simpler or in terms of line of code way to handle this problem. Okay, let's start with that. So we are going to have a function, and let's see how we do that for just a single element. The function we have is going to be a lambda. It takes the input and it would check the second element, right? Because we want to check the second element. So it takes the value of the dictionary. First of all, we have to pass the values of the dictionary, right? We don't care about the keys of this dictionary. So one thing to note is that all you need to pass to your function are the values in this dictionary. So this x is referring to a value in that dictionary, and x1 refers to the second component, which is the age. Right, so you have this function that would just do this, right? Let me just apply this function to this one and see if it does the job or not. It returns false because Kyle, our third student here, is only 16 years old, and we're returning true only if the x1, the second component, the age, is beyond 18. So we can continue on this. We can have this function. So we can use filter to apply this function to. So this is our function. I could have used f here, right? Because that's just, one may prefer one versus the other, but I could have used f. I can apply f, and here is the collection that I have to use. So I am going to use my students' data, but I'm only interested in the values, right? So remember, we could have accessed only the keys or values of a dictionary. This is how you would do that. So this function is going to be applied to the values only of that dictionary, and we ignore the keys. If you do this, you would get a filter object. You need to cast it to a list to see what you have. So this list are all the values in that dictionary for which the second element, indicator of the age, is greater than 18. The question posed to you was count the number of students. So you can apply the length function to count this. So it's getting a bit sophisticated in terms of notation here, but that's ultimately what we are doing. So if you want, I can kind of break it into simple components. So I'm going to create a list of older than 18. This is one technique. When you are giving the names to variables, it's better that these names are, they carry some meaning so that the code is more readable. Right, so if you do this, you have created a list of all the values in that dictionary. And then later on, you need to print the length of that list of older than 18, which is 2. So, or ultimately, you can just combine them in one line of code like the one. All of these are doing the same. So it's the purpose of introducing things like list comprehension, map, and filter, and then later on reduce, is to give you this big picture that Python has capabilities to do multiple lines of code, let's say 5 or 6 lines of code in one line of code. Those utilities are list comprehension, map, filter, and then reduce. And as I mentioned, you could have looped through this dictionary, take the values out, and check the age component and just count them all the way to the end. But these are faster approaches as well, because the Python interpreter has been optimizing for using map, reduce, and filter to apply to different types of lists, sets, or dictionaries. Let's take a look at another example. We will want to use map to apply a function into a list. I'm going to define my list as a list of numbers, this time integers, 2, 4, 5, and the goal here is to have all the components of this list square root. So again, we can use map and lambda together. Here is how we are going to do that. We have lambda x, this is how you square, and this is our function f square. And we are going to use map to apply f square to all the elements in L1. If you do this, it will give you that, okay, this object is ready. You probably need to cast it to a proper data structure to be able to observe the output. If you do so, then you have to basically just apply a list here and have them all printed. Once you run this, you can see 4, 16, and 25. So we just see another example, simple one, to use a combination of lambda and map to apply a function to all the components of a collection, and mostly we are working with lists here. One thing to notice here is that defining a function using lambda is a technique by itself, and applying that function to a collection or a list with map is another thing to notice. There are two separate things here, and they should not necessarily come with each other, which is what we are going to do in the next step. We are going to define a function, define a new function, this time not using lambda, and apply that function to a list or a collection. So we have that same list of 2, 4, 5. This time I'm going to define a square function. I know a square function exists, but I'm just going to define a function for the sake of learning that approach. So I'm going to call it square it n, and this function, all it does is that it just returns the square of a variable, right? That's the function. So you see, we are not using lambda to define a function, we are just trying a user-defined function. And we are going to map this function to the same list and just cast it to a list, because this is an object to be able to visualize those numbers. So this is just applying map to a user-defined function instead of, and that user-defined function is defined like this and not with lambda. So far we have used map as one of the utilities, and what map does is that it applies a function to all the components of a collection. So the length of the input is the same as the length of the output. There are other applications where you may want to filter a list based on specific conditions. You can again use a for loop in its explicit format to do so, and then have a condition or if-else statement inside the for loop to do so. But let us try the elegant way of using the so-called filter utility. So let me define a list of numbers like this. So what I want to do is that I would like to use the filter function to return all the multiples of 3, right? So out of this list, I'm only interested in the multiples of 3, which are 3, 6, and 9. So I'm going to use lambda to define a function. The function is called div by 3, lambda x, and this is like this, right? So this is just going to return, let's actually try this. Oh, oops, we have an error here. Let us try this div by 3 and see how it works in general for the. So I'm going to use div by 3 on, let's say, 5. I'm going to get false because it 5%3 is not 0, right? So it's checking whether a number is a multiple of 3 or not. If it's a multiple of 3, this condition is satisfied, so a true would be returned. So if I use 6, I'm going to get a true, right? Okay. So that's a proper function we are looking for. It is returning 3 if the number is a multiple of 3. So I am going to do the following. I'm going to have filter keyword applied using a function applied to my list. So this is very much like the map in which the inputs are a function, like here, and the second input is a list or a collection. The only difference here is that this one is applying this function to the list, but the output is some sort of a boolean, so you would get some of those elements filtered out and some of them filtered in, right? So if I apply this filter utility and then the function and my list, I'm gonna put them all in div and I'm gonna print div, right? So div here is again like an object, so we need to cast it to a list and then have it printed. So as you can see, I am getting a subset of my original list, where now only multiples of 3 are left. And that's because this filter is going to apply this function to a list, and this function has this binary boolean type of output where the output is true only for multiples of 3. The last utility to be discussed in this session is reduce. Reduce is a function or a method under functools library. So if you want to reduce, you have to do this. You have to go to the functools library and import reduce. And here's the application that is very applicable to. Let's say you have a list of numbers from, let's say, range of numbers from 1 to 7. Right, that's and you want to multiply all these numbers together. So you want to multiply 1 by 2 by 3 and hence all the way to the 6. As you may know, the one way to do it is to have a for loop which is looping through this list and multiply them one at a time together and then generate the output. Very much like map and filter, reduce gives us this utility to do this in a much faster and nicer way. So we can define a function using lambda. Let me define the function which takes 2 input, right, and returns the multiplication of these 2, right? And again, I think this is the first time we are defining lambda on 2 input. Mostly we are using it on 1 input, and then this was a boolean output, 1 input boolean output, 1 input square root square of the output. Square in the output, and or like an example, 1 input upper case version in the output. This is the first time that we are defining a 2 input lambda function. I'm gonna just apply to 2 or 3. I'm gonna get 6. So you can call reduce, you can call f, or this one. The first input, again, like a map and filter, the first input is your function and the second input is your list. And I'm gonna call this q, and I'm gonna just have q printed. Oops, I made a syntax over here. Okay, so this is if you like, it is like kind of like 6 factorial here. You have 6 multiplied by 5, and yeah, if you do it, you'll get 720. So the difference here is that you're not mapping a function to all the components or elements of a list, and you are not filtering out the components. So you are just applying a function on the entire list in a kind of a pairwise format, right? Multiplying 1 by 2, the result by 3, the result by 4. So the function that you are going to pass to reduce should be a function which would get 2 input and 1 output. Now let us just summarize what we've learned on map, filter, and reduce. As mentioned, these functions bring a bit of functional programming to Python. All 3 of these are convenience functions that can be replaced with list comprehensions or loops, but provide a more elegant and shortened approach to some problems. We first learned about map. Map function iterates through all the items in a given collection or list and execute that function that we passed as an argument on each of the elements of that collection. Similar to map, filter takes a function and a collection and creates a new list, but with the difference that the new list contains only elements that satisfy a certain condition. Finally, we talked about reduce, and we learned that reduce works differently than map and filter. It does not return a new list based on a function and the collection we passed. Instead, it returns a single value, which is the outcome of applying the function to the elements of that collection.